Hello everyone, welcome back to the video. So today we are going to be going over types of energy, specifically how can we distinguish potential energy from kinetic energy. Your due now is to explain what the difference is between exothermic and endothermic reactions. You may look back at your notes if you need to. And you do not have homework tonight, but when you see the next slide, you might reconsider. So, due now. What is the difference between an exothermic and endothermic reaction? Remember, exo is a word that generally refers to the release of something. Thermic is another way of describing heat energy. So, exothermic is the release of energy. Endothermic, meanwhile, is the absorption of energy. Now, let me stress, I would never, ever tell you about a pop quiz coming up, because that would be ruining my integrity as a teacher, especially that I need to know if you actually know the material rather than just cramming the material the night before. But Cool Guy Clyde might. Whoa, it's Cool Guy Clyde. He's the coolest kid in school. I hear he dresses up for Spirit Day every day. And I heard that he knows about all the quizzes. Yo, Cool Guy Clyde said. Miss Wizzle was given a 10-point quiz on states of matter, separating mixtures, physical versus chemical change, and substance versus mixtures on Thursday this week. That's tomorrow. It's 5 questions, but don't tell her I told you. But also note that Cool Guy Clyde comes in clutch with the deets. So, let me tell you those details. The first question would generally either ask you about a solid, liquid, or gas, and would ask, how would you describe it in terms of shape and volume? Second question would go into a realistic experience, as in I would give you a real scenario and you would have to try to tell me how you would separate the mixture. So for example, oh no, Miss Whistle's trapped on a beach. How would she separate the salt from the water? Boil the water. Go through something called evaporation. Third type of question, I will give you a scenario and you tell me whether it's a physical or chemical change. So for example, let's say I take a chainsaw to the door. That is a physical change because I am not changing the chemical composition of the door. Meanwhile, let's say I set the door on fire. That is a chemical change because I have changed the chemical composition of the door. Fourth, I may give you a compound or an element or a mixture. And I'd ask you to tell me, is this a compound, element, or mixture? So, for example, if your compound or element ends with the letter S, the letter L, or the letter G, it is a substance. Specifically, depending on the amount of your symbols, it is either an element or a compound. If there's only one symbol, or it's one symbol with the number 2 next to it, that would be considered an element. So the same element with the number 2 next to it, that is a diatomic element. That's an element that naturally comes in pairs. Still considered an element. If you have 2 or more different elements, that is considered a compound. Now, how do you know if it's a mixture? If your compound ends with AQ at the end, that means that you have an aqueous solution, which means that is a solution that is mixed with water. So that is inherently a mixture. That is the fourth one. And finally, the fifth question I would be giving you is, I'd give you some sort of well-known item, whether it is a smoothie or a salad, and I would ask you guys to tell me whether this is a homogeneous mixture or a heterogeneous mixture. So for example, a heterogeneous mixture is not uniformly mixed. So an example would be like a salad. I can easily pick out the tomatoes because it's not uniformly mixed. Meanwhile, a smoothie would be a homogeneous mixture because I cannot easily take out the pieces of a smoothie. In fact, I can't stick my hand in a smoothie and take out a banana. That's just not how it works. It's blended. It's uniformly mixed. So keep that in mind. So, what is energy? Good question. Energy is the capacity of doing work. Specifically, its units are in joules, J, or kilojoules, KJ. You're going to need to know those units, especially when we go over heat formulas tomorrow and Friday. There are 2 types of energy. The first is your potential energy. The second is your kinetic energy. So your potential energy is simply the energy that is stored in a chemical bond. Meanwhile, kinetic energy is the energy of motion. Specifically, kinetic energy is measured in temperature. So as your temperature increases, your kinetic energy increases. And as your temperature decreases, your kinetic energy decreases. The way I can tell the difference between the two is I have this little jingle. So what I would do is I would just walk around the room and go, I'm walking down the street. I'm walking down the street. I'm using my kinetic energy. And then I would stop and go, stop! Potential energy. So again, in this scenario, I'm walking around the room while I'm singing about kinetic energy, because kinetic energy is the energy of motion. Next, we've got the law of conservation of energy and mass. You should know this like the back of your hand. Neither mass nor energy can be created or destroyed. It can only be transferred from one form to another. So for example, let's say I set my door on fire. Originally, my mass of the door, let's say it's probably about 300 grams. It's not actually 300 grams, it's a lot more than that, but let's say it's 300 grams. As soon as I set it on fire and I find the mass of the ashes have a mass of 100 grams. Some of you might be thinking, oh no, the mass has been lost. Not necessarily. What we did not take the mass of was the smoke, the gas that was released when the door was set on fire. And that gas plus the mass of these pile of ashes would equal the total mass of the door, seeing that the mass is conserved. It was just changed from being one part of the door to being partially in gaseous form and partially in a solid form. Same thing with energy. Energy is conserved. So basically in this topic for today that I'm talking about, it's not necessarily that we need to identify what energy goes with what, but rather we look at the chain of the reactions. We look at the pathway of that energy. Oh, sorry. So what are your different types of energy? There are a few different types. First, we've got light energy. Then we have electrical, chemical, heat energy, mechanical, and atomic/nuclear energy. I want to stress that during the year this year, we're really going to be focusing on chemical energy, heat energy, and we already finished a unit that covered nuclear energy. The rest of the types of energy, we don't necessarily cover it too much in depth in this course. But with that said, I still want to give you the definitions of them just so you are aware of what they are in case you're ever asked about them. First thing we look at is light energy. This is the energy associated with light waves and other forms of electromagnetic radiation. Now, the thing that I find easiest with light energy is, or the thing that I like to associate the most with light energy is the sun. The sun is the main source of our light energy. And it is something, and yes, we can talk about our light bulbs. It is a source of light energy as well, but our light bulb source for that light energy is electrical. Meanwhile, the sun has no source. It's just light energy. And we can convert that light energy into electrical energy. Speaking of which, electrical energy. Now, I don't really want to focus on the light bulb here. I more want to focus on where the light bulb is getting its energy from, so it turns into light. Simply, electrical energy. Think of an outlet for a second, or rather, a charger for your phone. The plug part of your charger goes into an outlet, and that electrical energy travels up the wire into your phone so that it will eventually be charged using electrical energy. And again, to stress, electrical energy is just the energy associated with electrical currents or just the flow of electrons. We're going to talk a little bit about electrical energy once we get into our redox unit, but we're really not going to cover it too much. Electrical energy is more of a topic in physics. Chemical energy, this is one of our big ones. Chemical energy is associated with a chemical change, basically breaking or forming bonds. So anytime you see a reaction happening in a lab, that is chemical energy. Chemical energy can also occur in places that we don't realize. Like, for example, in our cars, when we turn the ignition on, what happens is there's a reaction in our gas tank that creates energy. That is a chemical reaction that is occurring in there. So again, that chemical reactions occur more often than we think. It even occurs in our phones or in these AA, AAA batteries. More about how it happens a little bit later in the school year, but this actually will help us eventually answer the question, why our cell phone batteries tend to kind of stink after 2 years. Heat energy. This is another type of energy that we're really going to talk a lot about this year, especially in this unit. Heat energy is associated with the temperature of a substance. So again, we also take into consideration heat of vaporization, heat of fusion. Again, more on that as we get further into the unit. Mechanical energy. Mechanical energy is the energy associated with doing work. What I tend to like to think of are like bicycle chains, gears, gadgets, when I think about mechanical energy. Another way I like to think of it, mechanical energy can also be a motion that you do. So if you're waving your hand, that would be considered a form of mechanical energy because it involves the movement of things in order to be able to achieve that work. Lastly, atomic and nuclear. We went over nuclear a lot last unit, but basically this is the energy associated with change in mass of atoms and the energy that binds the atoms together. So anytime an atom is broken or split, or anytime an atom is formed, that is considered nuclear energy. Nuclear energy also tends to be the main source for a lot of our different sources of energy. So, for example, the light in your room. Well, if we start from the beginning, it's probably going to be in a nuclear power plant upstate. That nuclear energy is going to be transferred into electrical energy, which is going to travel to your house. And that electrical energy will have to be turned to mechanical for you to turn on the light switch. And again, back to electrical. And finally, when it gets to your light bulb and your light bulb lights up, now it is light energy. Learning check. As ice cools from 273 Kelvin to 263 Kelvin, the average kinetic energy of its molecule will. Now remember what I said in the beginning of the topic. The kinetic energy is going to decrease because remember, the temperature is a measure of the kinetic energy of matter. So as your temperature is decreasing, kinetic energy will also decrease. It has a direct relationship. And finally, your rules for energy and chemical change. Now this is going to get into some stuff that we are going to cover more in depth later in the year, but I just want you to be familiar with some of the terms that I'm going to introduce to you. First rule, all chemical reactions require some sort of energy to occur. Chemical bonds are forces of attraction that hold atoms, elements, and compounds and molecules together. A chemical bond stores energy, so it's got potential energy. For a reaction to occur, a chemical must absorb enough energy to break the bond that it's holding its atoms together. And that type of energy is known as the activation energy. The way I like to think of it is that the activation energy is the energy required to activate a reaction. Anyways, thank you for watching. At this point, what I'd like you to do is go to the exit ticket. And on the exit ticket today, it is asking you to give me one form of energy. And I would like you, in your own words, to describe what that form of energy is. And as always, thank you for listening. Remember, guys, study for your quiz. And I hope you have a wonderful day.